In this video, we are going to discuss about state space model for two area system, and we all know the state space representation is one of the way of representing the control system. It is dealt with the digital control system, and in which we are going to describe the entire system in the form of first order differential equations. And by considering the actual input coming into a particular system and also the external values coming into the system as inputs, and the each and every stages within a system which is having an evaluation over time, we are going to consider for deriving such state space model. And here we are taking these actual inputs as a command signal coming into the load frequency control blocks from speed changer, that is del PC1 and del PC2 are the actual control inputs. So we are taking that as U1 and U2, and this is the representation for the state space model. And here we have to find this x dot. X dot is nothing but dx by dt. So this is the first order in the form of first order differential equation. So we have to find this value, and it is having a relation between the actual input and external inputs, and also the each and every stages in the input. So each and every stage we are calling that as a state variables. So our first thing is we have to obtain the matrix values for A, B and F. A is the it's a matrix. A matrix is nothing but the transmission matrix, that is a matrix of state variables, and B is the input matrix for the control input vector U, and F is the disturbance matrix for the vector P. So for obtaining such matrices, we require the each and every stages of the two area load frequency control. So the last output what we are going to obtain from two area LFC is frequency response for both areas, and then the turbine input, and then the input coming into the generator. So these are going to be taken as the state variables. In addition to that, since we are talking about two area system, we are going to include the change in tie line power also. Here we have taken the change in tie line power with respect to area 1, and we know the relation between area 1 and area 2 in with respect to tie line powers, right? So from this equation we can get the value for tie line power 2 with respect to control area 2. So that we have taken only one value, that is del p tie 1. So it is, all these are in the Laplace transform. So now what we are going to do is, in order to get this dx by dt, we are going to convert all these two into a time domain. So by taking inverse Laplace for all the 7 equations, we can get the values of del f1, del f2, all these are in time domain. So till del p tie 1, all these are in a time domain. So we have taken from s domain to time domain by taking inverse Laplace transform. So now we can by substituting the values in the respective matrices, we can obtain A matrix, B matrix and F matrix. So if we are having any numerical value with us for time constants and gain for all the state variables, by substituting the values, numerical values in those matrices, we can get the output value for the entire two area system. So this is one of the way of calculating the output, this response for the entire the combo of two areas. So